Hi, and welcome to the ARM What Is Program series. In each episode, we explore a tech topic to give you insight and perspective into some of today's hottest design trends. I'm Brian Fuller, Editor-in-Chief at ARM, and today we're going to find out what is processor security. And to help us with that, I want to introduce Erik Jacobson, Marketing Director, Architecture and Technology with ARM. When he's not helping us understand what is processor security, Erik likes to go running, but he assures us he's not a marathoner. So let's get started. Erik, what exactly is processor security?
A lot of IT cybersecurity, a lot of the industry focuses at the application level and on the operational side of things. So doing things like spam detection, intercepting phishing attacks through your email systems, mitigating distributed denial of service attacks on enterprises, all that good stuff, which is really necessary and really important. Processor security, however, is at a much lower level. Processor level security focuses on the instructions that are actually being executed on the CPUs, and the hardware support that is put in place to defend at that level. If we go back a long time in processor history, the very first processors, there was implicit trust. And I use the word trust deliberately here, between the processor and the instructions that run on the processor. No one thought about this back in I guess the early 70s type thing, when just getting code up and running on a CPU was hard enough. But as the years have gone by, in fact decades, that implicit relationship, or the implicit trust relationship, has matured perhaps. As attackers look to gain access, especially to information in different parts of the memory that they're not meant to get to, so the processor can no longer implicitly trust the instructions that it's asked to run. So over those same years, decades, we've had hardware components added, like system memory management units, SMMUs, etc. Which may have been introduced originally for flexibility, such as multitasking, but actually have found increasing use in defending against these type of attacks. And so this control of access to memory, so attacks might be, for instance, a return-orientated attack, a ROP attack, or a jump-orientated attack. Nowadays, we actually have processor architecture in place to help and support defend against these attacks. So this is at the processor level, and we define these different technologies. We group them into defensive execution technologies, isolation technologies. It could be things like branch target identification and memory tagging. And for isolation, trust zone and secure SEL2. So there's a lot of these technologies that we've put in place, which at the very lowest level of the actual processor core help to defend against those attacks.
Is the responsibility for processor security, does that lie with the IP provider, or is that more of a partnership between IP provider and processor vendor?
We might define, as ARM, working with our partners, we might define these processor security architecture features. As I mentioned, something like memory tagging, but we don't actually implement the silicon, so they have to be implemented. And then a lot of these hardware support features we're putting in have to be supported with firmware and software. So such as trusted firmware, which is an open source project. So they need to be deployed. They need to work on the systems. So ideally, the various people and companies in the supply chain need to be involved. They need to actually use the firmware and use the software, etc. So there's a whole lot of links, effectively, that need to be put in place for an effective system. So that's why it's everyone's responsibility.
So a lot of work obviously being done at the processor level. You've mentioned all the work around compartmentalization. Security is still obviously a big headline these days that we read almost every day in the newspapers and see on television. How do you see processor security evolving in the coming years?
The most obvious thing is, say the attacks are always evolving, right? So there are always new attack vectors. And a few years ago, we had Spectre and Meltdown, which was a whole new class of attacks. You know, it opened up a whole new way of thinking that a lot of people in the industry, in different companies, in lots of different competitor companies, hadn't actually thought about. So to stay ahead of the game, we need to do our own research. We need to collaborate in research, and we need to keep an eye on what's going on in the market. So there's that new type of attack that's always coming up, but it's also just doing the basics really well, you know. And I think I mentioned government and regulation earlier. Industry certifications, such as PSA certified in the IoT market, there's nothing incredibly radically new about it. It's just solid, sound, good practice. And as I talked about earlier, the whole ecosystem needs to be using those best principles that we've evolved around. You know, there's a project we're participating in, funded by the UK government actually, called Morello, which is about an improved memory protection architecture. It's can be quite a radical technology, so everyone has to be in the loop, whether it's ARM, whether it's a silicon vendor, whether it's an operating system vendor, you know. And finally, the one of the new paradigms is confidential computing, which actually separates the responsibility for who owns and operates on the data from where it's being run, and that's a paradigm shift.
Is there something you can compare this to in another industry?
So one of the analogies I've heard is, just as cars have improved in safety for the driver over the years with ABS, airbags, advanced driver aids, so processors have improved in their security. So in a car, the driver hasn't had to do anything and it's got safer for them. Just so with an application piece of software, the underlying hardware, the processor security has improved.
Well, thanks, Erik. It's incredibly reassuring to know that the industry is working so tirelessly and relentlessly to secure our devices, and obviously thinking well into the future. Now, check out all our other What Is programs here and be sure to subscribe, because we'll be adding more as the year progresses. Thanks for watching.